Welcome to the DIY Honda Garage channel. DTC P0108 indicates a problem with the manifold absolute pressure MAP sensor in a 2022 Honda Civic. This diagnostic trouble code arises when the MAP sensor generates an output voltage beyond the specified limit of 4.49 volts, leading the powertrain control module (PCM) to identify an abnormality. The MAP sensor is vital as it measures the manifold pressure in the intake manifold, which is essential for calculating engine load and fuel injection. Its location is typically near the throttle body or on the intake manifold itself, ensuring accurate readings of air pressure changes. Elevated voltage signals can trigger performance issues, such as poor fuel efficiency or increased emissions. Therefore, pinpointing the causes and addressing them promptly is crucial to restoring optimal vehicle performance. The DTC P0108 involves the manifold absolute pressure (MAP) and the powertrain control module (PCM). The MAP sensor measures the pressure of air entering the engine. It reports this pressure to the PCM, which uses this data to adjust fuel injection to optimize engine performance. The location of the MAP sensor is typically on the intake manifold or near the throttle body, making it accessible for inspections. The PCM, located usually within the engine compartment, processes the signals received from the MAP sensor to regulate engine functions accordingly. If this sensor sends an excessively high voltage signal, the PCM interprets it as a malfunction, which is logged as DTC P0108. Understanding these components and their functions is critical for effective troubleshooting. There are several possible causes for DTC P0108. A faulty MAP sensor is often the primary suspect. When the sensor malfunctions, it might send an inaccurate high-voltage signal to the PCM. Additionally, damaged wiring or loose connections in the sensor circuit can also produce high-voltage readings. Open circuits or short circuits are common culprits, resulting in erratic voltage signals. Lastly, in rare cases, a malfunctioning PCM could misinterpret sensor data, causing it to register incorrectly high voltage values. Each of these possibilities can lead to performance issues and requires systematic testing to isolate the problem effectively. Symptoms associated with DTC P0108 typically include poor engine performance, which may manifest as hesitation, stalling, or reduced acceleration. These issues arise because the engine control unit struggles to optimize the air-fuel mixture due to inaccurate data from the MAP sensor. Increased emissions can also occur, since the incorrect fuel mixture can lead to incomplete combustion, causing a rise in pollutants emitted. Another common symptom is the illumination of the check engine light on the dashboard, indicating a fault has been detected by the PCM. Vigilantly monitoring these symptoms can aid in early diagnostics and prompt necessary interventions. The first troubleshooting step for DTC P0108 involves turning the vehicle's ignition to the on position while ensuring the engine is not started. During this step, use the Honda Diagnostic System (HDS) to read the MAP sensor voltage values. If the HDS indicates a MAP sensor voltage greater than 4.49 volts, it confirms that the failure is present. Failure to obtain a normal value at this stage indicates a potential abnormality that needs further exploration, emphasizing the importance of precise diagnostics as the foundation for effective repairs. Following this, if the voltage is indeed high, troubleshooting will continue to determine whether the issue lies with the MAP sensor itself or with related wiring and components. The second troubleshooting step requires inspecting the MAP sensor by first disconnecting its 3P connector. This ensures that there is no interference while testing. Next, Jump terminals number 1 and number 2 on the map sensor connector using a jumper wire. Once this is done, turn the vehicle ignition to the on position again and check the HDS for the map sensor voltage reading. The expectations for normal conditions are that the HDS map sensor voltage should display a value less than 4.49 volts. If this value is normal, it suggests that the fault lies within the map sensor itself, while abnormal readings may indicate issues with the wiring or the PCM. In the third step of troubleshooting, both the map sensor and PCM connectors must be disconnected to perform specific wire inspections. This entails checking the PB open wire and the SG1 open wire for any abnormalities. Utilizing an ohm meter, confirm that the resistance in these wires is less than 1 ohm, indicating a good connection. If the wires are intact and within the normal resistance range, it eliminates these as potential causes for the high voltage problem. However, if either wire fails this inspection, it suggests a break or fault within the circuit, warranting repairs to restore proper connections and functionality. The final troubleshooting step focuses on the PCM itself. Assuming that previous inspections showed normal conditions with the map sensor and wiring, the suspicion shifts to the PCM being the root cause of the issue. This step involves a detailed inspection of the PCM for any faults, as damage within the PCM can render it incapable of processing sensor signals correctly. The outcome of this inspection should confirm whether the PCM indeed has a malfunction, necessitating its replacement if found defective. Diagnosing the PCM accurately is crucial, as it is the command center that orchestrates numerous engine functions, relying heavily on inputs from the map sensor and other components. After completing all necessary repairs, it's vital to perform a final verification to ensure that the issue has been resolved. This includes conducting a function test of the vehicle to confirm that engine performance has returned to normal levels. Clear any diagnostic trouble codes detected during the previous steps using the Honda Diagnostic System HDS. Following this, retest the vehicle by cycling the ignition and observing the map sensor voltage readings while in on mode. This check will verify whether the previous high voltage issue has been corrected and whether the PCM is now receiving accurate sensor inputs. It's an essential step in the repair process to ensure that no further issues persist post-repair. To prevent issues similar to DTC P0108 from arising in the future, regular maintenance is crucial. Schedule periodic inspections of the map sensor and associated wiring to identify potential degradation or damage early. Routine cleaning of the map sensor, as well as maintaining clear connections, can help in ensuring it functions reliably over time. Keeping the engine's air intake and components clean is equally important, as contaminants can affect sensor readings. Additionally, employing proper diagnostic tools like the HDS routinely can help monitor vehicle health, thereby preemptively detecting irregularities before they manifest into failures. Developing a preventive maintenance schedule is essential in prolonging the life of the components and improving overall vehicle performance. In conclusion, understanding and diagnosing DTC P0108 is critical for maintaining optimal vehicle performance. This trouble code highlights the importance of the map sensor within the air-fuel management system. Each component involved, including the map sensor, wiring, and PCM, is vital for ensuring that the vehicle runs efficiently. Performing accurate diagnostics to identify the specific cause of the high voltage reading lets technicians implement corrective actions effectively. Following a structured diagnostic process helps in resolving issues promptly and prevents recurrence. A robust preventive maintenance approach ensures that all components remain in good working order, facilitating long-term reliability and performance in the Honda Civic and similar models. Please like and subscribe to the channel. See you next time.